While the IoT will have a number of different wired and wireless protocols, we see many common ones at the edge of the network. These devices are often wireless and require low power. Wi-Fi, Zigbee and Thread, Bluetooth, and even proprietary technologies are being used. Each of these have specific advantages such as large throughput, mesh networking, connectivity to phones, and even long range. Silicon Labs understands that one size does not fit all, so we enable our customers with a choice of wireless solutions through ICs, SoCs, and modules. In this slide, we're going to talk about the three different families that make up the Wireless Gecko platform. Standard technologies like Thread, Zigbee, and Bluetooth are based on 2.4 gigahertz. This is mostly due to the global appeal of 2.4, as a single product can work worldwide. However, when you get into proprietary protocols, sub-gigahertz has some compelling attributes, including range, low power, and the ability to penetrate material better than 2.4. In proprietary applications, they focus on these differentiators to solve specific needs. FlexGecko is focused on proprietary solutions and can support 2.4 gigahertz and sub-gigahertz. Because proprietary stacks often require less memory than standard-based stacks, the FlexGecko has options from 32K all the way to 1 megabyte. There are over 40 SoCs in the portfolio supporting 2.4 gigahertz and sub-gigahertz. BlueGecko is focused on Bluetooth Low Energy technology, but can also support proprietary applications for multi-protocol and multiband with both 2.4 and sub-gigahertz. With 128K to 1 meg and over 50 parts, including both SoCs and modules, developers are assured to find the right part for their products. And finally, the Mighty Gecko is a superset part. While it is focused on 2.4 mesh, including Zigbee and Thread, it supports Bluetooth Low Energy and can support both 2.4 gigahertz and sub-gigahertz for proprietary applications. This makes it a great option for customers that want a single design to support multiple options or want the capability for a product in the field to support multiple protocols. With 256K up to 1 mega flash and over 40 parts, including SoCs and modules, it is the ideal multi-protocol solution. When it comes to home and building automation, the most desired way of controlling and configuring a system is through a mobile phone app. Therefore, there is heavy demand to include Bluetooth connectivity to all IoT devices so that they can be controlled and configured by a mobile phone. This is why multi-protocol solutions are essential to any IoT system. The term multi-protocol is used broadly and can mean many different things. It is very important to find a common language. So here are some definitions to help explain the various use cases we have at Silicon Labs. The first one is programmable. Programmable multi-protocol simply means you are able to program the desired protocol at manufacturing time. For example, you could have a single door lock design that can be configured for either Zigbee or Bluetooth during manufacturing. The second use case is switched multi-protocol. This is where an application can switch between two different protocols via a bootloader. For example, a device can be commissioned using Bluetooth and a mobile phone, but then switch or bootload into a Zigbee application to then join a mesh network. The third use case is dynamic multi-protocol. This involves time slicing between two different protocols such as Bluetooth and Zigbee. For example, you could have a live Bluetooth connection from your mobile phone that actively controls a Zigbee lighting network. Concurrent is the final use case, and this is a special type of dynamic multi-protocol. This is for hybrid networks that share the same RF channel. You can actually time slice between Zigbee and Thread and maintain simultaneous connections for both. There are of course limitations because you cannot receive both a Zigbee packet and a Thread packet at the same time. However, this might be an option for low-cost, lower-end gateways. For the switch multi-protocol use case we are dealing with here, The application must account for the time taken to boot load from one wireless protocol to another. Depending upon where you store the firmware images and how large they are, a boot load and switch could take about 8 seconds. Therefore, while this method is suitable for future-proofing and commissioning use cases, it has its limits and does not enable true real-time switching between the protocols. One example of dynamic multiprotocol at work is the use of Bluetooth beacons to enable proximity-aware applications alongside a mesh network, such as a retail lighting network. If a store is equipped with a Zigbee-controlled lighting system, the Zigbee-enabled lighting fixtures could also be made to transmit a Bluetooth beacon periodically. Lighting in a store is an ideal way of determining location, as lights tend to be spaced evenly throughout the area. Here, a Bluetooth beacon is used to advertise the device's presence and services. By using RSSI, or received signal strength measurements, on a periodic received packets, it is possible for a mobile device to determine how close it is to any given beacon and whether it is moving closer to it or further away. Monitoring multiple beacons can provide quite accurate understanding of where the mobile device is in the store. To help with device selection, here's a table to help you select which architecture is right for you based on your multi-protocol needs. In the first column, you will see the different family of devices. In the second column, you will see the different memory configurations associated with these devices, and the remaining columns highlight the different multi-protocol use cases and helps to provide you a matrix of recommendations as well as notes. In summary, multi-protocol solutions are coming, and both consumers and manufacturers are paving the way with innovations. Multi-protocol combines both Bluetooth and 802.15.4, enabling connectivity to mobile phones for ease of configuration and control. So I'd just like to close in saying thank you for spending the time, and hopefully you found this presentation helpful in learning about multi-protocol solutions on the Wireless Gecko platform.